In this lesson, we're going to be working some compound interest word problems. There are two hurdles that you'll need to get through in Module 4, two main ones. One is knowing which formula to use for which problem, and the other one is knowing how to enter it in your calculator. And we're going to talk a little bit of both of those and a little bit about both of those in this lesson as well. So first of all, problem number 1 states, if $1,000 is deposited in an account that pays 5% annual interest, compounded annually, find the balance after 4 years. So how do we know which formula to use? One thing I do want to point out is that you are given a formula sheet in Module 4, so I've posted that in Moodle right above this lesson, and it looks like this. And so the first two formulas that we see are the simple interest formula, the future value for simple interest formula, and then the third one, compound interest formula for interest paid in times per year. And so because the problem states compound interest, we're going to use this formula here. A is equal to P times 1 plus the APR divided by N raised to the N times Y. We also know that it's not the savings plan formula, and the difference between number 3 and number 4 is how many times you are contributing to this account. So for formula number 3, this is a one-time deposit. Or we can also say a lump sum. So maybe you got a stimulus check and you want to take that entire stimulus check and deposit it into a savings account one time and leave it alone for a couple years so that maybe it will grow and you'll have enough to put as a deposit on a car. So that's when you have like a lump sum of money and you're just going to take that and deposit it into an account and let it alone and let it grow. The difference between that and formula number 4, which is the savings plan formula, is this formula is used when you are making regular payments, and it's usually monthly. So for instance, maybe you are depositing $25 every month into a savings account out of your check that you get for work. So this is regular, monthly deposits. Clean that up a little bit. All right, so back to our worksheet. So in this problem, number 1, we have to pick out some very important information. That important information is how much we're depositing, which is called the principal, what our annual interest rate is, and that needs to be converted to a decimal, how many times we're compounding, and then for how many years we are compounding. So, just to reiterate, in our formula, remember for number 1, we have A is equal to P times 1 plus your APR divided by N raised to the N times T. So P is your principal. And again, that's how much you're depositing into the account, or the 1,000. Your APR is your interest rate, but it has to be converted to a decimal. So if you remember, you take 5, you divide it by 100, which means you're going to move the decimal 2 places to the left, which gives you 0.05. N is the number of times you compound in a year. And if it's annually, that means once. So N is equal to 1. And then finally, t is equal to the number of years you are compounding. And in this case, that's going to be 4. So if we plug this into our formula, we're going to get A is equal to 1,000 times parentheses 1 plus 0.05 divided by 1 raised to the 1 times 4. And entering it in your calculator, like I said, is another hurdle that you'll have to get over. I like to clean mine up as much as I can before I go to my calculator. So 0.05 divided by 1 is just 0.05. And 1 plus 0.05 is 1.05. And then 1 times 4 is 4. So it's raised to the 4th power. Now, you can enter this in your calculator just like you see it if you have a calculator that has parentheses. Or if you don't, you'll have to know how to use the order of operations. And that is what the Scientific Calculator Guide tells you how to do, is to enter it in a calculator that doesn't know the order of operations or that doesn't have parentheses that work correctly. So you'll see here, what it's telling you to do is first plug the values into the formula. And again, this sheet is right beside the formula sheet in Moodle. And then you'll simplify the exponent, so the n times y, which we found to be 4. And then in your calculator, you're going to type the following. So you're going to do the 0.05 divided by n. We already did that and found it to be 0.05 because our n is 1. Add 1, we already did that because 1 plus 0.05 is 1.05. Then you're going to use the exponent calculator, and it can be different depending on the type of calculator you have. Some of them, the button looks like this. It'll be x raised to the y. Some of them have it as y raised to the x. And then some of them have it as a caret. So this is called a caret key, and it looks like this over here. So it on a TI-84, that's what this is a picture of. The caret key is found to be right about here. If you have the TI-30X X2S, I think the caret key is right here. All right, so you'll just have to look for that key that looks like an arrow going up. Then after you raise it to the exponent, then you're going to multiply by p. Because remember, you do exponents before you do multiplication. So that's what I meant by order of operations. So entering that in the calculator, hopefully you come up with $1,215.51. Now, I really want you to have your calculator out and enter that in to make sure you get the right answer. Because like I said, that's one of the battles you have to face when doing Module 4. All right, let's move on to number 2. Number 2 is very similar to number 1. Again, we're taking a lump sum of money, we're depositing into an account. The difference is that in number 2, it's compounded semi-annually, which means twice a year. So in number 2, n is actually going to equal 2. P is 800. Our APR is 0.08 this time. And then T is 10 years. All right. So going to our formula again, we have A is equal to 800 times 1 plus 0.08 divided by 2 raised to the 2 times 10. Sorry. And 0.08 divided by 2 is 0.04. And 1 plus 0.04. Sorry, pen. So that's going to give me 800 times 1.04 raised to the 20th. And if you do that in your calculator, you should get $1,752.90. Now, I have a question for you before we move on to number 3. And that is, can we determine how much interest has been paid in this account? Because we only put $800 into the account, but now we have almost $2,000. The answer is yes, but a lot of students will try to look at the formula sheet to determine which formula you use to find the amount of interest that was paid. And that is not actually on the sheet. It's actually a bit of common sense. So if you think about it, if we deposited $800, but now we have $1,700, and we haven't personally put any more into the account, then the total interest is going to be the balance, the ending balance, or the amount in the account minus the principal. So in this case, it's going to be 1752.90 minus $800, which is what we put into it. And so the interest is $952.90. All right. Number 3, I'm not going to work step by step with you. It is done exactly like number 2. The only difference in number 3 is that it is compounded monthly. All right. So in that case, n is going to be 12. So when you're entering it in your formula, it should look like this. A is equal to 50,000 for number 3 times 1 plus 0.03 divided by 12 raised to the 12 times 5. And if you do that in your calculator, you should get 58,000 $80.84. And then the amount of interest, because number 3 is actually asking for the amount of interest, so that's going to be the 58,000 minus the 50,000, and so the total interest for number 3, so this was number 2, is going to be your 58,080.84 minus 50,000, and that's going to give you $8,080.84. So that's it for this video. We're going to pick up with numbers 4 and 5 on the next page of your lesson. If you have any questions, reach out to your instructor during their office hours or student hours, or you can access NetTutor to get some tutoring.